Hello everybody, welcome to the last video for cumulative review number 14. We're going to start here with number 19. So if we take a look at this polynomial, we eventually want to graph it, but first we want to find all this information. So the highest degree of this polynomial is 4. The leading coefficient is the number in front of the term with the highest degree, which is -1. The possible number of turns is really the degree minus 1, so that would be 3 possible turns. The number of zeros is the same as the degree, so it would be 4 zeros or 4 x-intercepts. The end behavior, we need to think about what this graph looks like before we graph it. If we have a negative lead coefficient, that means the graph is going to be facing down. And if we have something that is a power of 4, it's going to be more parabola-like because the exponent is even. If this were an odd exponent, it would look more like a snake, but if it's an even, it's going to be parabola-like. So it's facing down and looks like a parabola, so my graph is probably going to look something like that, which means my end behavior would be, as x goes to infinity, the graph is going down to a negative infinity, and as x is going to negative infinity, the graph is also pointing downwards in both cases, so both end behavior answers are negative infinity. So over here, if I'd like to find my roots or my x-intercepts, I need to set y equal to 0. So 0 equals negative x to the fourth plus 9x squared. I'm going to take a little GCF out here. I'm going to take out a negative x squared. Might as well get rid of the negative issue. If I do that and divide that out, I am left with x squared. 9x squared divided by negative x squared is negative 9. If I continue to factor this, this is going to be x plus 3, x minus 3. So I have 3 possible zeros. So I have negative x squared equals 0, x plus 3 equals 0, x minus 3 equals 0. So my 3 possible zeros are x equals 0, x equals negative 3, and x equals positive 3. So I'm going to put those, on the line here. So 0, 0, negative 3, 0, and 3, 0. Now it asks about multiplicity. To remind you, multiplicity means, so if the graph is going to, so if it has a multiplicity of 2, let me erase that and try that again. Multiplicity of 2, the graph is going to bounce. Come on. If we have a multiplicity of 1, the graph is going to go through the x-axis. So, multiplicity means the number of times a root occurs. So we need to be careful here with this first root. Technically, if I solve this equation, we would divide by the negative, and then we would take the square root of both sides. When we take a square root, we technically have plus or minus 0. Now, positive and negative 0 is really just the answer of 0, but the plus and minus means that this has a multiplicity of 2, which means when we graph it, it's going to bounce. Both of these roots, however, when we factor it, only occur one time. So this has a multiplicity of 1, and this also has a multiplicity of 1. And so if I'd like to graph this, I'm going to put those x-intercepts at 0, 0, 3, 0, and negative 3, 0. I know that my end behavior starts down below, so I'm just going to draw a sketch. I'm going to start down here. I'm going to go towards the x-intercept of negative 3, 0. Multiplicity of 1 means I go through the 0. I have to go back towards the other 0, but at 0, 0, we have a multiplicity of 2, which means you're going to bounce. So you're going to bounce here, go back up, go back down to 3, 0. I missed a little bit, sorry about that. This, it goes through because we have a multiplicity of 1. So my graph is going to look something like that. We could figure out exactly how high this graph goes if you'd like to plug in a value, like you could plug in the x value of 2 into the original function here, and you could get a y value out so your graph is more accurate, but I'm looking for just a sketch really. Write as a complex number a plus bi. So this problem is here to remind you about another thing that might help you in calculus with imaginary numbers. So to remind you, we know that I squared equals negative 1. So that means that I cubed is going to be I squared times I, which is negative 1 times I. So we have negative I. So this is important. This is important. Then if we have I to the fourth, that is really I squared times I squared, which is negative 1 times negative 1. So I to the fourth is really equal to 1. These are the important things. So if I come over here and I'd like to simplify this, we have negative 6 times I to the 11th. Now, I to the 11th is not one of the three that we know well, so we're going to break I to the 11th into something we do know. I would suggest using I to the 4th as many times as you can, because plugging in a 1 is easier than anything else. So if I'm going to split I to the 11th, I to the 4th, and I to the 4th is already I to the 8th. So then we want to keep, we could do I to the 3rd to get to 11, but I'm going to suggest doing I squared and then I, because I think plugging in negative 1 and positive 1 is easier than negative I. So this is really negative 6 times 1 times negative 1 times I. Negative times negative is positive, so this is really a positive 6i in the end. So the second part here, we have plus 9 times the square root of negative 16 is 4i, so this is really plus 36i. Then we have plus 2. If we combine these like terms, we have 42i plus 2, but if we want our answer in a plus bi, it is real plus imaginary, so this would be our final answer. And the last problem of our cumulative review, number 21, goes back to a little bit of trig identities. Given that tangent of x equals negative 3/4 and sine of y is 5/13, we want to find these two identities which are on an identity sheet, which you will be given if this question is here on your test. So both angles are in quadrant 2. So we're going to draw two separate pictures here. Tangent of x, we draw a little triangle in quadrant 2, put an x here. Tangent is opposite over adjacent, so we have 3/4. The negative has to go in the correct position. In the second quadrant, the x is negative and the y is positive. This second one of y is also in the second quadrant. Sine is opposite over hypotenuse, so we have 5/13 there. So if I wanted to continue both of these triangles, this is a 3, 4, 5 triple here. This is a 5, 12, 13 triple there. In this situation, again, the x is negative because it's in the second quadrant. Now that we have our two triangles, we can answer these questions. If you have your identity sheet in front of you, this is an identity. Cosine of x plus y is the same as cosine of x, cosine of y, minus sine x, sine y. And so what we're going to do is plug in the ratios that we can find from our triangles. So I'll use colors here. I'll circle this one in green. Cosine of x is adjacent over hypotenuse, so this is negative 4/5. Sine of x, right here, is going to be opposite over hypotenuse, which is 3/5. This triangle in purple, cosine of y is going to be negative 12/13, and sine of y is going to be 5/13. So at this point, we just need to multiply and combine. This fraction together would be a positive 48/65 minus a 15/65. If I add these two fractions, because they have the same denominator, my final answer is 33/65. Part B, sine of 2x. This identity on your identity sheet, this is equal to 2 sine x cosine of x. So I am only going to use green on this problem because notice the only angle I have is x. So I only care about this first triangle. So 2 multiplied by two separate ratios because sine and cosine are just ratios on a triangle. Sine of x is 3/5, opposite over hypotenuse. Cosine is adjacent over hypotenuse. Remember that this is really 2/1, so all you have to do is multiply across. Multiplying fractions is easier than adding them. 2 times 3 times negative 4 is negative 24. 1 times 5 is 25. So there's my ratio answer for the sine of 2x. All right, guys, that is the end of this last video. Feel free to rewatch anything you might need. Thank you.